Hello there, welcome to Maths Vibe. My name is Enosh. Today we'll be tackling a question on standard forms. I hope you're ready. Let's move. Okay, so the question for today is, without using mathematical table or calculator, evaluate 0.0048 times 0.81 all over 0.0027 times 0.004, leaving the answer in standard form. Okay, so with standard forms, um, when you have very small numbers or very huge numbers, sometimes it is difficult to work with these numbers. Okay, for instance, if I have 0 sorry, if I have 0.000041, and I have to keep working with such a number, you realize that to keep writing this number will delay my work. Okay, so standard form help us to write numbers such as this or even smaller than this in a way that will be easier to work with. So for instance, this 0.00, we can rewrite it in the form 4.1 times 10 exponent negative 1, 2, 3, 4, 5, 6, negative 6 to there. So this is the standard form of this number. Sometimes the zeros could be more. You could have what? About 100 zeros. If you want to work with such number, it will be difficult for you to keep what? Repeating this number of zeros. So you will just change the number into a form which is easier to work with. So that's all about standard forms, making the number smaller but not changing its value. Because at the end of the day, if you multiply 10 exponent negative 4 by 4.1, you get back this number. Okay, but it's easier to work with it if it is in this form. Okay, so that's all about standard form. All right, so now let's see how we can tackle our question for the day. Okay, so the question we have here is 0.0048. So when you look at this, we have what? 48 here, and then we have 4 here, and 4 is a perfect factor of 48. 27 is also a perfect factor of 81. So if we can do something to the question so that we'll have 48 here, 81 here, 4 here, and 27 here, then it will be easier for us to cancel. So what comes to mind is, let's remove the decimal point from here to this side, because mind you, the question stated that we should not use mathematical table or calculator. So the examiners will expect to see some key elements in your solution which will tell us that you actually understand the concept we are working with. Okay, so now we move the decimal point from here to what? To in front of the 8. And moving that, you will move the decimal point 1, 2, 3, 4 times. And this number, because this number is a small number, we are going to multiply it by 10 raised to the power negative 4. Because at the end of the day, if we multiply the 10 raised to the power negative 4 by the 48, we expect to get back our 0.0048. Okay, so the same thing we'll do to the 81. We'll move the decimal point 1, 2 times. Okay, so we'll be multiplying the 81 times 10 raised to the power negative 2. This side is also 4. Okay, we'll move the decimal point 4 times. So we'll obviously multiply this one also by 10 raised to the power negative 4. This part is 3. So multiplying 4 times 10 raised to the power negative 3. Okay, so this is how it looks like. So we've been able to isolate the 48, the 81, the 4, and the 27. So now we can do some cancellation. 4 will go into itself 1, 4 will go into 48. How many times? 12 times. And then 27 will cancel 81 3 times. And 10 exponent negative 4 will also cancel 10 exponent negative 4 once, which means they are gone. So now we are left with 12 times 3 times 10 exponent negative 2 all over 10 exponent negative 3. So we have something like this. So now the next step is to multiply the 12 times the 3, and we'll see what we arrive at. So now we have 36 times 10 exponent negative 2 all over 10 exponent negative 3. So what do we do to this? So we learn in indices that whenever we have the same base dividing the same base, and we can just we can repeat the base, and then we'll subtract the exponent of the denominator from the exponent of the numerator. So in this case, we have 10 exponent negative 2, 10 exponent negative 3, which means we have the same basis, and therefore we can what manipulate the exponents. So in this case, our m here is negative 2 and our n is negative 3. But remember that the minus here is going to affect the negative 3. Okay, so let's see how it's going to look like. So we're going to have 36 times 10 exponent negative 2 minus 3, because the exponent of the denominator is what? Minus 3, and indices is saying that we should subtract the exponent of the denominator from the numerator. The numerator is negative 2 minus the exponent of the denominator, which is negative 3. So we have 36 times 10 exponent negative 2 minus 3, and minus becomes what? Positive. Good. So now if we rewrite it, we'll have 36 times 10 exponent negative 2 plus 3. Good. And 10 exponent negative 2 plus 3 is the same as the negative 2 plus 3 will give you 1. Negative 2 plus 3 is the same as 3 minus 2. So we are going to have 36 times 10 exponent 1. You can decide not to write the 1. It doesn't matter. So now we have 36 times 10, but this is not in the standard form. In standard form, we expect the decimal point to come after the first number. So what can we do to change this into a standard form? And from here to here, we are going to have something like this. So there's one here. If you move the decimal point to the left, and this is a huge number, so if you are changing it into a standard form, it means our index is going to be positive, and hence we move the decimal point 1, so we should add 1 to the exponent level that is already there. So we are going to have 3.6 times 10 exponent 2, and this is our final answer, and it is in a standard form because this is what is required when we are dealing with standard form. So you can see that these numerous numbers over here, we've been able to reduce it into a number that we can easily work with.
Thank you for watching, and don't forget to keep practicing. Cheers.